Hello, grade 4. Our science lesson for this week is about electricity. And throughout this lesson, we are going to learn what is electricity. We are going to describe how charged particles interact with one another. And also, we are going to identify conductors and insulators of electricity. And finally, we are going to learn about magnets and magnetism. First of all, let us start our lesson by learning what is electricity. You already know that you are all made of atoms. What are atoms? Atoms are the building blocks of all matter. Atoms are so small that you cannot even see them without a special microscope. Atoms are made up of even smaller particles that we call protons, neutrons, and electrons. The main difference between protons, electrons, and neutrons is their electric charge. What is the electric charge? Electric charge is a property of a particle that affects how it behaves around other particles. Let's see how does this electric charge differ between protons, electrons, and neutrons. Protons have a positive charge, +1. Electrons have a negative charge, -1. Neutrons are neutral, they have no charge. When an atom has equal numbers of protons and electrons, the positive charges and negative charges cancel each other, so the atom itself has no charge. Now, this picture shows that protons and neutrons are found in a region of the atom called the nucleus. The neutrons are represented by white spheres and protons are represented in red spheres. So protons and neutrons are found in a region of the atom called the nucleus. Electrons are represented in blue spheres. Electrons are found in a region of mostly empty space called the electron cloud. Now, let's look at this picture. Each of these atoms has the same number of protons and electrons, so both atoms are neutral. But an electron from the atom on the left moves to the atom on the right. So the atom on the left now has a charge of +1 and the atom on the right has a charge of -1. Atoms sometimes gain or lose electrons. This gain or loss causes an atom to have an unequal number of positive and negative charges. For example, if an atom with 9 protons and 9 electrons gains an electron, the atom will have a charge of -1. If a neutral atom loses an electron, the number of protons will no longer balance the number of electrons, so the atom will have a charge of +1. Now, let us discover how do opposites attract. Let's look at this picture. Particles with the same charge repel or push away from one another. Particles with opposite charges attract one another or pull together. We have to know that electric charges can build up on objects. This build-up is called static electricity. Static means not moving. So, as we said before, objects with opposite electric charges attract each other, and objects with the same charge repel each other. Let's take an example. Have you ever had a bad hair day? Your hair sticks out in every direction and won't lie flat? What causes that? When you brush your hair, electrons move from each strand of hair to the brush. Soon, all the strands are positively charged. All the strands having the same charge causes them to repel one another and stick out. A charged object can attract a neutral object. For example, if you rub a balloon on your hair, the balloon picks up extra electrons that give it a negative charge. Now we are going to talk about electrostatic discharge and lightning. Thunderstorms can be scary, and lightning can be dangerous. As we already said before, static electricity is a buildup of charges on an object. Charges stay on an object until it comes close to an object that has a different charge. For example, as you walk across a carpet, electrons move from the carpet to you. And because electrons repel each other, they spread out all over your body. When you touch something, the electrons jump from your finger to the object. Let's see how do these electrons move. An object with a negative charge is placed near an object with a positive charge. Electrons jump from the negatively charged object to the positively charged object. This jumping is called an electrostatic discharge. During a thunderstorm, tiny raindrops or ice particles bump into each other. These collisions cause an electric charge to build in the clouds. Positive charges form at the top of a cloud and on the ground, and negative charges form near the bottom of a cloud. When the difference in charge between a cloud and the ground is great enough, there is a huge electrostatic discharge that we call lightning. So, when lightning strikes, it can catch objects on fire. A tree struck by lightning may split. And now we are going to learn about electric currents. When electric charges have a path to follow, they move in steady flow. This flow of charges is called an electric current. So let's look at this picture. In this copper wire, electrons are moving through the wire. Now, you can use an electric current to do many kinds of useful work. We use electric currents usually for cooking food, lighting a room, and producing sound. We have to know that a battery is a source of electric current. Chemical reactions in a battery provide the energy that causes the electrons to flow. For example, our cell phones or MP3 players use electrical energy that comes from batteries. Now, we have to know also that most of the electric current used in schools, homes, and businesses does not come from batteries. Instead, it comes from an electricity generating station or energy station. And there are many types of energy stations. Energy stations change different types of energy such as chemical, nuclear, or mechanical energy into electrical energy. Wires carry the electrical energy from the generating station to every outlet in your home. Now, we are going to learn the difference between a conductor and insulator. A conductor, by definition, is a material that readily allows electric charges to pass through it. For example, electric charges flow easily through metals and some liquids. But an insulator is a material that resists the flow of electric charges. For example, the rubber and plastic used in the protective clothing do not allow electric charges to flow through them. Let's look at this picture. This worker's clothing is made up of insulators. The clothing will not allow electric charges to flow through it if the worker accidentally touches the wrong wires. In the second picture, you can see that the parts of a plug that you hold and the covering on the wire are insulators. The metal prongs that go into the outlet are good conductors. And in the third picture, we can see that electrical appliances work when electric charges flow through them. The parts that carry electric charges are made from conductors. Insulators are wrapped around the conductors to make appliances safe to handle. Let's see what are electric circuits. A circuit, by definition, is a path along which electric charges can flow. We have to know that for an electrical device to work, the circuit must form a complete loop. This type of circuit is called a closed circuit. There are no breaks in its path. If a loose wire gets disconnected, the path is broken and charges cannot flow. This type of circuit is called an open circuit. Now, many circuits have a switch. A switch controls the flow of charges by opening and closing the circuit. Now let's look at this picture. It shows that we have two types of circuits. We have the open circuit and the closed circuit. When the switch in a circuit is open, the circuit is not complete. Electric charges cannot flow, so the light stays off. When the switch is closed, the circuit is complete. Electric charges can flow through it to light up the bulb. Now, let's discover together what are the types of electric circuits. We have to know that we have two types of electric circuits. We have the series circuit and the parallel circuit. A series circuit has only one path for electric charges to follow. If any part of the path breaks, the circuit is open and nothing works. A circuit with several different paths for the charges to follow is called a parallel circuit. So, if one part of the circuit breaks, the charges can still flow along the other parts. So, let's look at the first picture. It shows series circuits. In a series circuit, electric charges must follow a single path. The charged particles move from the battery's positive terminal to its negative terminal. So, if one light bulb in a series circuit burns out, all of the lights go out because the circuit is broken. In the second picture, we have parallel circuits. In this parallel circuit, electric charges can flow through both the top loop and the bottom loop. If one part of a parallel circuit breaks, only that part of the circuit stops working. Now, let's see what are the uses of electricity. Electricity has many uses. We need electricity to make a television and a video game system work. We need electricity to use an electric stove. And we need electricity to make a hairdryer work. Now, we have to know that many electrical devices have electric motors. An electric motor, by definition, is a machine that changes electrical energy into energy of motion. For example, an electric fan uses electric motor to move air. A refrigerator uses an electric motor to keep foods cold. Finally, to end our lesson, we are going to talk about magnets and magnetism. Magnets have been used for thousands of years. What is a magnet? A magnet, by definition, is an object that attracts iron and a few other metals. We have to know that people make magnets, but they are also found in nature. Now, what is magnetism? Magnetism is a physical property of matter. Magnets push and pull because of their magnetic field. What is the magnetic field? A magnetic field is the space around the magnet where the force of the magnet acts. We have to know that each magnet has two ends or poles. A magnetic pole is the part of a magnet where its magnetic field is the strongest. Now, one end is called the south-seeking pole or S-pole. The other is the north-seeking pole or N-pole. Two N-poles or two S-poles are similar or like poles. If you place the N-poles of two magnets near each other, they repel or push away. Two S-poles push away too. So, in general, like poles repel each other. An N pole and S pole are unlike poles. So, if you place unlike poles of two magnets near each other, they attract or pull toward each other. Now, let's take a look together at this important picture. This picture shows a bar magnet. The iron fillings that we see around the magnet show the shape of the magnetic field. If we look closely, we can notice that the magnetic forces are strongest around the poles. That's it for this week, grade 4. Thank you for watching.